Hi everyone, we are in the polynomials and rational functions unit now. This is our third unit in this trimester. So let's get started with our first standard being transformations. And I'm going to take 2 days to cover this. I'm going to give you this chart, but let's go over it first. So when we're talking about transformations, we're talking about shifting a graph either up or down, left, right. We might be stretching it or compressing it or flipping it over the x-axis or flipping it over the y-axis. So let's look at what that might look like. If I say f of x plus c here, that means I have something like a plus 2 on the outside of my function, and that's actually going to be a shift up. So an example of that would be x squared plus 2, where I'd be up 2 on my graph. Now, if I had a minus 2 instead, that's going to be a shifting down. So we're looking at this one right here, and that's considered a minus c or a shift down, and that would actually look like this. It'd still be a happy parabola, but I would be shifted down, specifically down 2. Now, if I look at something in parentheses, that would mean something where I have parentheses x plus 2 squared. I'd actually be shifting left and right. In other words, a horizontal shift. And it's the opposite of what you think it is. Here I have a plus 2, but it would actually be a left 2. Okay, so that graph would look something like this. I'm shifted a little bit to the left of the origin. And similarly, if I had a function with a minus 2 in parentheses, that would be a right c units, in this case right 2, so I'd be somewhere over here. So this should all be fairly familiar, but at this point now we're going to get into some unfamiliar territory. So first of all, if I have my negative on the outside of the function, I'm looking at this one right here, that would be something like a negative x squared. And if you want, you could even put parentheses here, but it's really the same thing as what I had before. That would be a reflection over the x-axis. So that would be something that looks like this. Remember, it was this, and now it's going to that upside down parabola. It's been reflected over the x-axis. Now, this next one here, if you have the negative inside the parentheses, sometimes it makes a big difference. And actually, in this case, if I were to do parentheses negative x squared, that actually just gives me x squared, which is the same exact graph as the parent function. But you can see how this graph actually is reflected over the y-axis like our chart tells us it is. And so if you don't believe me, kind of think about what would this look like reflected over the y-axis. Well, it would be this right here. And also vice versa, that original would reflect over to there. So in this case, it doesn't really look like it changes the graph, but it does essentially reflect it over the y-axis. All right, now we're going to talk about stretching and compressing. If I have an a value on the outside, in other words, if I have a number on the outside of my function like I do here, and that number is greater than 1, in other words, it's not a fraction, that means that it's going to vertically stretch. That's going to look like something like this. And if you will, kind of imagine taking your fingers and grabbing the ends of this and pulling them up, vertically stretching that red parabola up until you get it to look like the green. So that's what a vertical stretch is, and that happens when your number is outside of your function and it's greater than 1. Now, what happens if I have a function that has a fraction, a number less than 1 on the outside like this? Well, this would be a vertical compression, and that actually looks something like this. It's almost like taking your hands and putting one hand on the bottom of this red thing and one hand kind of on the top. Here's my hand. And smushing down, taking your hands and vertically smushing that red thing down until it looks like the green thing. So that is a vertical compression, and that happens when you have a fraction on the outside. All right, now let's talk about a horizontal compression. So that's when you have a number in the inside of your parentheses and that number happens to be greater than 1. So in this case, we have a 2x parentheses squared. Notice that 2 is bigger than 1. This is a horizontal compression. Okay, I want you to think about horizontally taking your hands. You have one hand on this side and one hand on this side, and then horizontally compressing it, meaning you're kind of pushing it to go inside or getting smushed. So you're horizontally compressing it, and that would mean you would end up looking like that. And you might say, hey, Ms. Sorensen, that looks like a vertical stretch. And you're right, it actually ends up being the same thing. But you want to think about taking this red thing and pushing it in, horizontally compressing it. All right, the next one I want to look at is if we have a number on the inside that happens to be a fraction. Okay, if we have a number on the inside that happens to be a fraction, that's going to be a horizontal stretch, meaning we're going to take this red thing and we're going to pull it out horizontally. So you're going to end up having something that looks wide, like that. And you might say, hey, Ms. Sorensen, that kind of looks like the vertical compression, and you're correct, they are the same thing. So what have we kind of taken away from this? Well, we can imagine that the vertical stretch is the same thing as the horizontal compression. And then alternatively, the vertical compression and the horizontal stretch are essentially the same thing. It just matters about where the value of A is. So let's go ahead and let's look more into the horizontal and the vertical shift. I want you to see that this blue function right here is our parent function. It just goes right from the origin. It goes through every box there. That is being shifted in orange. How so? Well, in this case, left 1. Notice how we took this blue parent function and made it go left 1. Another example is this turquoise color right here. Here, we're taking our parent function in this dark blue right there, and we're going left 1, down 3. Remember, it's the opposite of what we think inside the grouping symbols, and it's what we think it should be outside. So we're taking our blue parent function, going left 1, and then down 3. And folks, that should be review. So let's go ahead and let's apply this to a graph that we have studied. We know how to graph e to the x, and I'm going to put my parent function y equals e to the x in black. So graphing that, we've had this on our quiz before. We know e to the 0 is 1, and we also know that when we plug in 1, we get 2.7. So I'm going to put those 2 points there, and I'm going to draw my parent function as best I can. And so now looking at this function here, I want to determine the shift. Okay, the shift is going to be a right 3 and then an up 2. So I'm going to actually graph this in a different color because I'm fancy like that. Everyone says, Ms. Sorensen, you are fancy. And I'm like, yeah, I'm really fancy. So I'm going to take that and I'm going to go right 3 up 2. So I'm going to take this point right here and I'm going to go right 3, 1, 2, 3, and then I'm going to go up 2. There I am. Okay, now I did have another point. Remember, it was that 1, 2.7 right there. So I'm going to take that and go right 3, 1, 2, 3, and I'm going to go up 2. Something like that. And it actually really helps to take your axis, not just your axis, but in this case your asymptote. Here's my blue thing. And I'm going to take it and I'm going to go up 2 with it. I can certainly take that dotted line and go right 3 up 2, but you're basically going to have this right here. So I've taken that and shifted it right 3 up 2. So now you can see that my graph is going to look like this. I've essentially taken that black parent function, I've taken the 2 points, and I've moved them right 3 up 2. And that's it, folks. I'm done with that one. Let's talk a little bit about reflecting over the x-axis and the y-axis. So how can we tell the difference between these two things? That's certainly very confusing. Well, if I have the function f of x equals x squared minus 9, and I do a negative f of x with that, that's implying that I'm doing a negative parentheses. Remember, it's on the outside here. I'm going to have my x squared minus 9. Well, all I have to do is just distribute that. And so I get a negative x squared and a plus 9, which is indicated in purple right here. So this blue is in fact one of these types of problems where you've got a negative on the outside, and this just happens to be what it looks like. And so my red is my parent function, right here is my parent function, and it's graphed there. And the purple one is after I put the negative out front like this and distributed it. And you can see that it did in fact reflect over the x-axis. Now on this problem over here, notice how the 3x gets changed to a negative, but the plus 2 does not, which tells me that this is actually an example of this problem. In other words, we are going to rewrite f of negative x, where I'm putting a negative x in for my x right there, and that gives me a negative 3x plus 2. And that gives me that green function here. And you can see that my purple and my green have been reflected over the y-axis this time. Whoa, zooming in like crazy. That's what happens when I try to slide to the next thing. All right, this next one has to do with vertical stretch and compression. And I'm actually going to take some time in class to go over this, but what I do want you to observe that is if the number is on the outside and it's a fraction, you can see in blue here that it gets vertically compressed. So that's going to be this example here when I have a fraction out in front. Versus if I have a number that's greater than 1, basically not a fraction out in front, it gets pulled up and pulled down vertically, meaning it gets kind of steeper like that. And again, I'm going to show you that in class because it's much easier to see with a hand visual. All right, last one I want to cover is this idea of horizontal compression and horizontal stretching. And so what we have here is in parentheses, we have a number that's greater than 1. So that's going to be this case right here where we're compressing it. And think about this as taking this blue thing and pushing it in horizontally, and that's how you get to the turquoise. And last but not least, thanks for sticking with me, if my a value is a fraction, which it is here, you're basically taking your blue parent function and you're pulling it out. You're actually stretching it horizontally and making it wider. Well, folks, that's all I really wanted to cover today. I do want you to try to cover graphing this. I know it's scary for your video problem, but if anyone can do it, it is my pre-calc class. See you tomorrow or today. Bye now.